let's do some con, my friends. Probability that Trudy succeeds on a given free throw is 80%. She's curious how many free throws she can expect to make in a sample in 12 free throws. So, like, there's a mathematical way to do that, right? But this is a simulation is like, let's say we don't know that. So I'm just going to make up a mathematical way to kind of run through the scenario a bunch of times and then do the math from there. So she simulated 25 samples of 12 free throws, 0.8 probability. So this would be like looking at a random digit table, assigning, say, like 0 through 7 to be a make, because that's 8 numbers, and then 8 to 9 to be a miss. And then you just run through, and every time you see a number, you write down whether it was a make or miss. And then what this is saying is, well, one of the times that we ran the experiment, they made 8 out of 15. 1, 2, 3, 4 out of the times, they made 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 of the times, they made 10. 9 of the times, they made 11, and 2 of the times, they made 12. So the probability that and there were 25 of these total, right? Probability that she succeeds at 10 or more free throws would be this one, and this one added up. I'm going to subtract, that's easier. There's 5 over here, so there must be 20 over there. So I don't know what it'll do. I'm going to put 20 over 25. That's 4/5. So they took it. So they don't even make you reduce. All right, 3-point shot, 20%. She's curious how many shots it will take her to make her first. Okay, so she just keeps doing it over and over. Well, not doing it over and over again, but she's going to simulate where 20% probability of being made. So maybe like 0 through 1 is a make, and 2 through 9 is a miss. So every time you just look at a random digit table. So say it says like 7, 8, 1, 0, 2, 4. You would go, okay, they missed, made it. So their first make was on the 3rd attempt, and you'd put a dot there. Then you'd go to like you just keep going. So a 2 is a miss, a 4 is a miss, let's say a 3 is a miss, then you get a 0. So then I don't know what number that is, but then you just record the next one. So use the results to estimate the probability that takes fewer than 7. So there are 50 of these dots. What's the probability that there are fewer than 7 dots? So the cutoff line is right here. Again, I'm going to count these because it's shorter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be 40 out of 50 because we want to know the ones on that side. Fewer than 7. Okay, fewer than 7 does not include 7. So there's 2 7s that should not be counted. My bad. 7 or more. I mean, I think you can almost just kind of stop reading the situation at some point and just say, okay, there's 5. So 5 out of 30. Oh my goodness. Oh, because you simulated 100 times. That's what happens when you try to be lazy and not do the problem. All right, let's go again. So there's 24 of those. Probably it takes more than 3 boxes. So that would be all of these. 9. So that's 15 out of the 24. All right, so hopefully that helps with that one. Let me jump to two-way tables, Venn diagrams, and probability. So let me talk through, this is a good one, this is a good example. So 17 out of 80, what this is saying, 17 out of 80 people were bride only. 42 out of 80 people, so let me put BR for bride. 42 were both. And then 20 were groom only, and there was one person there that didn't know the bride or the groom. So this little weirdo down here, some kind of wedding crasher or something. Are the events bride and groom mutually exclusive? Can they be true at the same time? So could you be a friend of the bride and a friend of the groom at the same time? Yes, all of these people are. If something's going to be mutually exclusive, this has to be 0, but then it wouldn't even be there. It would be like 2 circles that just didn't touch because there's no overlap. So this is not bride or groom. Okay. So the bride or groom, the probability here. Probability of A or B so you could say bride or groom, is the probability of A plus the probability of B, sweet, sweet handwriting, minus the probability of A and B. Another thing to watch out for here is instead of the word or, they might put this U. Instead of the word and, they might put this A. Well, it looks like an A, but without the middle part. So bride or groom. Well, the probability of A is 17 out of 80. Plus the probability of B. So that was bride. I'm calling A bride. So that's like A and B. The probability of groom is 20 out of 80. Nope, I'm wrong. Probability of bride is 59 out of 80 because this bride circle has 59 in it. The groom circle has 62. Minus the both circle, the both has 42. So this circle has 59, this circle has 62, but these 42 people have been counted twice, so we have to subtract them out so that they're only being counted once. So let me get what, 121 over 80, 121 minus 42 is 79. Oh yeah, that makes sense. So bride or the groom is everybody except this weirdo here, so it should be one less than 80 out of 80. Are Tuesday and Friday mutually exclusive? Yeah, that sure seems like it. I don't know how you're supposed to be born on a Tuesday and a Friday, so they can't both be true, Tuesday or Friday. So you would do the Tuesday, which is 90, the Friday, which is 70, and you would subtract overlap, but there's not any overlap. So you're just doing 160 out of, how many are there? 500. Two headlines. One's false, one's true. Probability that they believe the true one was 90%. All right, so now we're gonna take that info and Venn diagram the F out of it. 75% believe both headlines. I always start in the middle. This is the true one. This is the false one. 90% believe the true headline, but 75% we already counted for, so there's only 15% here. 82% believe the false headline, so this giant false circle has to be 82%. We've already used 0.75, so all that's left is 0.07. Are they mutually exclusive? No, because they can both occur at the same time. There is overlap. Believe true or false. So now we're doing that formula again. So I'm gonna try to write it out. A or B. So that's that notation right there means or. Equals the probability of A. And this formula is actually given to you on the formula sheet for the AP test. So you're allowed to use it during your test. So this is and. So the probability of A or B. So the probability of A is the probability that they believe the true headline. 90%, and it's because these two total up to 90%. Probability of B, 82%. Notice that these two numbers in the B circle add up to 82%. But if I stop there, now I'm at like 172% or 172 probability. That doesn't make any sense. So we got to subtract the overlap, which is the 0.75. And that should get me 0.97. So then this over here, if I'm right, would be 0.03 because the whole box should add up to 1. Nice one. All right, hopefully that helps.